This is Honors Algebra 2 Pre-Calculus. We're doing homework review for section 2.7 in Pre-Calculus, number 25 on page 184. This is a partial fractions decomposition problem. So this is already factored for me, which was nice. Thanks, textbook, for doing me the solid. This is a repeat linear factor, right? So it's an x, the factor is an x, and it just happens to be an x times another x. So I'm going to get two fractions from that, an a over an x plus a b over an x squared. Right? And then this is also a linear factor, so I'm going to get a c over an x plus 1, right? So when we have these repeat linear factors, especially when they're just an x squared or an x cubed or something, we're going to tend to all make the same mistake, which is when we get the common denominator, we accidentally don't remember that the denominator we want is exactly this denominator. So I have to ask myself, what is each one of these fractions missing relative to the original denominator? Well, the a fraction has an x already, so he's only missing one of the x's, and he's missing the x plus 1. So I'm going to times this guy by both the x and the x plus 1 on the top and the bottom. Right? The b fraction already has the whole x squared, so all he's missing is the x plus 1. And the c fraction already has the x plus 1, so all he's missing is the x squared, right? So the whole thing's missing an x squared. So if I then look at my numerators only, my numerators only would be 4x squared plus 2x minus 1, which remember is only a trick that I can do because the denominators are identical, which is why it's important that you make these denominators identical to the original. I have an a times an x plus 1, plus a b times the x plus 1, plus a c times the x squared. Now if I use my clever substitution, I should be able to find two of these variables very quickly, and then I can pick any other x to find the third. So if I pick x is 0, that's going to knock out anybody that just has an x sitting right next to the coefficient, right? So that's going to be 0 plus 0 plus, minus 1, my bad, minus 1, equals, well, that a has an x next to it, so that's going to be a 0 plus b times 1 plus a bunch of 0. So I'm going to get negative 1 is my b, right? And that was pretty straightforward. Then I'm going to plug in x's. If I plug in negative 1, I'll be able to knock out any of the x plus 1s. So when I do that, I'm going to get a 4 times a positive 1 plus a 2 times a negative 1 minus a 1 equals, when I plug in the negative 1, anybody with the x plus 1 is going to go away. So the a times this whole thing is going to go away, and the b times this whole thing is going to go away, and I'm just going to get plus c times what comes out to be a positive 1 because it's a negative 1 squared. So on this side, I have 4 minus 2 minus 1. Well, that's a 4 minus 3, so that's a 1 equals c, so I get my c as 1. Now that I know b and c, honestly, I can plug in any x value to find a. The only easy x value that I haven't used is x equals 1, so that's what I would suggest using. So if I plug in x as 1, right, I'm going to get 4 plus 2 minus 1 on this side. On this side, I'm going to have a, which I don't know, times 1 times 2, plus b, which I do know, is a negative 1 times 2, plus c, which I know is a 1 times 1. So now I can clean all this stuff up. On this side, I get a 6 minus 1, which is a 5, equals 2a. And then over here, I get a negative 2 and a plus 1, so I get minus 1. So I get 6 equals 2a, and I'm pretty sure I get a 3 for my a, right? So now that I know my a, b, and c, right, my job is just to plug back into my original expression with my a, b, and c. So I'm going to give myself a little bit of space by erasing over here, and that makes my final answer 3 over x, because that was a over x, plus my b, which is a negative 1 over x squared, plus my c, which was a 1 over x plus 1, and that should be my answer.